Okay, so we're still in geometry. This is Unit 2. Now it's number 34. We're going to use what we know about angle relationships to help us solve for x. So we have a variety of angle relationships. Right? We got vertical angles, we got supplements, we got complements, we got alternate interior, we got same side interior, corresponding angles, all these different vocabulary terms of all these different types of angles and how they relate to one another. So the first thing to do when you see a problem like this is to first of all establish, well, what is the relationship between these two angles? Okay, and then how can I set up an equation to establish that relationship or to visualize that relationship? So for instance, in the first one here, I see these two angles. Get the parallel lines cut by a transversal. I recognize that those two angles are what we call corresponding angles. And I know that corresponding angles are congruent. They have the same measure. So when I go to set up an equation for this, I'm going to set those two angles equal to each other. So 5x plus 7 equals 9x minus 63. And then we just solve for x here. So let's add 63 to both sides here. So 5x plus 70 equals 9x. We'll subtract 5x from this side, subtract 5x from that side. So 70 equals 4x. And divide both sides by 4. So x equals 70/4, or that's 35 halves. So I'd probably just leave it like that, 17.5 if you're into decimals. You could have it as that as well. But using corresponding angles being equal, create an equation to set them up equal to each other, and then we just solve for x from there. This next one, we have a little bit of a choice. Okay, in fact, I see about 3 or 4 relationships right off the bat right here. These two angles are supplementary. So 5x plus 21 and 20x plus 34, I'm going to add together to be 180. They're adjacent supplements or linear pair. We also have 20x plus 34 and 12x minus 14, which are also supplementary. They're same side interiors, so they're also going to add to 180 degrees. And I also see that we have a pair of alternate interior angles here. 5x plus 21 and 12x minus 14 are equal. So I have a variety of options I can set up for an equation. No matter which one we use, we'll get the same answer for x. I like setting things equal to each other, so I'm going to go along with 5x plus 21 equals 12x minus 14. That's because these are alternate interior angles, so they would have to be the same measure. So let's subtract 5x over to this side. So we have 21 equals 7x minus 14. Let's add 14 over to this side. So 35 equals 7x. We divide everything by 7, and x equals 5. So number of choices there with our relationship, right? It's good to know them all. It's good to have options there, especially if you encounter a problem with a variety of expressions for different angles. You can always use one to work around to get the other one, and then once you know one angle, then you know all the angles are the same, or you can find all the supplements. So knowing the relationships in a diagram like this really kind of helps you to dissect it into different angles that there are. If you have any questions about those types of relationships, feel free to leave a comment. Otherwise, as always, you can subscribe, like, or share to our geometry videos.